Hello and welcome. Today, we'll be diving into the process of creating a complex layout in Paragon. In this video, we'll cover two key topics: roof and floor layout. By the end, you'll have a solid understanding of how to handle more intricate designs efficiently. Let's get started. To begin, we'll start by laying out the bearing elements using the provided reference plan. First, we'll add the exterior walls. Since the wall heights vary, we can begin with the lowest one, setting it to 9 feet 1 inch with a thickness of 5.5 inches. We'll adjust the heights later to ensure they match the correct plan elevations. For proper alignment, we'll set the justification to back and place the walls in a clockwise direction. We'll use the direction plus length input method to ensure precise placement. Input the dimensions here, then click the arrow button to specify the direction. After that, click Insert and Repeat, or press Enter to insert the bearing and proceed with the next insertion. Continue placing bearings until the exterior bearings are fully closed. You can refer to the plan for exact dimensions or follow along as I input them. Now that we've placed the last bearing, let's click Insert and Close to finalize the bearing envelope insertion. Next, we'll adjust the left point of this exterior bearing. Click the Pick button for the left point. Then, select this location, as we'll be converting the bearings below it into a beam later. Now let's add the beam at the top, but we need to input work lines first as a guide. Offset to the right, add another work line here, and then one more here. Once the work lines are in place, we'll insert the bearing envelope for the beam. Using the point selection insertion method, we'll place the bearings around the work lines we just set. After that, we can delete the work lines, either by selecting them individually or using the Delete All Work Lines option. Next, let's adjust the bearing top heights to match their correct elevations. Moving on to these bearings at the top, notice that when we multi-select, the bearings aren't being selected because the selection filter is set to Truss Envelope. Always ensure that the correct element type is selected when making a selection. If you ever place a bearing incorrectly, you can easily adjust its left and right points to reposition it accurately. For example, in this case, we made an error when placing this bearing based on the provided plans. To correct it, let's first add a work line as a guide. Then, we'll repick the right point of this bearing. Next, we'll adjust this by repicking both its left and right points. Notice that we can't snap the left point to the correct position. This is because orthogonal mode is enabled. Simply turn it off, and now we can snap the point correctly. Finally, adjust the right point, and this bearing is now in the correct position. When multi-selecting, the properties of selected elements will display a single value if they are the same across all selected items. However, if any property differs, you'll see various instead. Always double-check your selection to prevent unintended changes. Now let's finish adjusting the top and bottom heights accordingly. Now let's check if the bearings were added correctly and ensure everything is placed properly. Some bearings still need their bottom heights adjusted, so let's make those adjustments here in the 3D view. Simply click these two and update the bottom height. As you can see, the changes update in real time. Let's change the bearing render mode to solid for a more pronounced visualization. A useful feature in 3D mode is that any selection you make remains active even when switching back to 2D. If you need to focus on that selection in the layout, simply click Focus on Selection, and the scene will zoom in to the selected elements. This is especially helpful when identifying an issue in 3D and quickly locating it in the layout. For example, in this case, we need this component to be extended here. Now we can proceed with adding roof planes for this plan. We'll adjust any necessary adjustments to the bearing envelopes later if needed. Right-click on the scene and select Roof Plane. Set the slope according to the plan, adjust the overhang, leave these settings unchanged, and modify the subfascia thickness as required. Next, click on the existing bearing where you want to place the plane. You'll see the roof plane appear with arrows indicating the slope direction. Click Insert and Repeat to continue adding roof planes without closing the insertion window. Repeat this process until all roof planes are placed. If a roof plane is placed on the wrong bearing, simply click the Pick button again and select the correct bearing. The incorrect placement will be removed and the new one will be added. Now, let's add a gable outlooker plane for other planes to intersect against. While you could use a work line for this, it can also be done directly. Set the slope to 90 degrees, change the unit to degrees, set the overhang to 0, and adjust the cantilever length to match the outlooker distance. Click on the necessary bearings until all required roof planes are placed. If you notice any missing roof planes, simply adjust the settings as needed and click on the bearing where the plane should be placed. Now we're ready to cut the planes. Select a roof plane, then click Cut Plane and choose the roof planes or lines to cut against. To ensure a proper cut, follow the correct cutting direction, whether clockwise or counterclockwise, so that the intersections align correctly. For example, for this, let's cut in a counterclockwise direction. While cutting, hold Shift to make vertical cuts in a straight line. Once done, click Finish Cutting to finalize the operation. Repeat this process for the remaining roof planes until the roof layout is complete. Now that we're ready to add the ceiling planes, we first need to insert the interior load-bearing elements that will support them. Let's start by adding a work line as a reference for where the bearing stops. Next, we'll place another work line here for the sloped ceiling plane, and two more for the garage bearing wall. We'll add a new bearing instead of extending an existing one. We'll use the point selection method, but you can also use direction plus length if preferred. First, click on the left point, then select the right point. Add again here. And here, but we'll insert the bearing up to this point since the next section has a different height. Click Insert and repeat. Adjust the top height, and then select Insert and Close. Now let's remove the unnecessary work line and check the bearing heights in 3D view. Looking at it, we can see that this height should match the exterior wall. We could verify this in the plan, but for now, we'll go ahead and adjust the height directly in 3D. Let's also check the other bearings to ensure they are at the correct elevations. This one needs an adjustment. Click on it and modify the height. Same with this one. Let's update it as well. Now that we've adjusted everything, we can remove the extra work lines, except for this one, which we'll use for the sloped ceiling. We can always make further adjustments later if needed. So for now, let's move forward with adding the ceiling planes. Right-click on the scene and select Ceiling Plane. Set the slope according to the plan and ensure the settings are correct. Click on this wall to place the ceiling plane. Similar to roof planes, a triangle icon will appear, but in a different color to indicate a ceiling plane. Next, let's add the remaining ceiling planes. Once that's done, we're ready to cut them using the same process as the roof planes. Switching to 3D view, everything looks good so far. Now, let's add the flat ceiling planes. For this project, we need to define the flat planes separately since the ceiling has different elevations and slopes. This ensures the truss envelope follows the correct bottom profile. If all wall elevations were the same, we wouldn't need to add a ceiling plane, as the truss envelope would automatically align with the top height of the walls. Set the slope to 0 degrees and insert the flat plane. Click here and then cut where necessary. The result should look something like this. Now let's add the lower flat ceiling plane and cut it around the building. We'll include this area. No trusses are needed here based on the framing plan. Let's verify it in 3D view. Everything looks correctly placed. Now, let's check if the truss envelope correctly reads the ceiling planes. We'll insert one and check in 3D. At this point, we can see that the truss envelope didn't fully recognize the sloped bottom or the different wall heights. This happens because we need to add a vertical ceiling plane wherever there's a change in elevation. To fix this, let's add another ceiling plane and set the slope to 90 degrees. Place it here, and you'll notice a diamond icon instead of a triangle, indicating a vertical plane. Click Insert, then proceed with cutting the plane where needed. Looking at the roof plane in 3D, we can see the roof plane is angled upward. To ensure a proper cut, we need to start from this side and hold Shift to cut in a straight line. Next, we'll cut the vertical ceiling plane against this flat ceiling plane. Here's a tip. You can click directly in 3D view while cutting to make the process easier. Just select the ceiling and it will automatically cut against that plane. Finally, we'll make the last cut to complete the vertical ceiling plane. Cut here, and that completes the vertical plane successfully. It should now look like this. Now let's verify if the truss envelope correctly follows the ceiling profile. Looks like it worked. With that done, we can now move forward with adding the rest of the truss envelopes. Right-click the truss envelope and select Start Run. Then extend the run to this point and confirm the insertion. Next, we'll place a truss girder here to support the main trusses above. Set the ply to 2. Make sure Snap Against Bearing Envelope is turned on. This will speed up the insertion process, eliminating the need to manually lock to the base. Click here and insert to finalize. Now let's add the trusses that will rest on this girder. Right-click again to insert a single truss. Here, we can see that the envelope is snapping outside the bearing instead of inside. To fix this, ensure the justification is set correctly. Let's adjust it to back. Add the truss, click Insert and Start Run. Extend to this point and confirm. Add another truss run here by following the same steps we used earlier. Notice that it isn't snapping to the correct side as well. Simply adjust the justification to correct it. Insert and Start Run, and run until here. Let's check if the truss runs were added correctly. Everything looks good. Now let's move on to this area and add the truss runs here as well. Looking good as well. Let's see if we need to place more main trusses elsewhere. We'll do the same insertion here. Click, and let's do one final check before moving forward. It looks like we've added all the necessary main trusses. If we missed any, we can add them later. Let's go ahead and check the truss envelope profiles in 3D. This view helps us confirm that the trusses are aligning as intended and match our expected profile. Let's pan around and check if any adjustments are needed. As we can see, some trusses extend beyond their intended span, like these ones here, and others don't follow the expected roof profile, like these trusses. We'll fix this issue by refining their left and right points. Turn off 3D mode and adjust the affected trusses. To modify the endpoints of multiple trusses at once, insert a work line, set it as bounding, and position it where the trusses should stop. This method ensures trusses end precisely at the desired location. But if they've already been placed, you'll need to use Recalculate tool. For example, insert a bounding work line. Click here, check the bounding, and insert. Now we're ready to adjust the span of the trusses. Select the trusses that need correction. Right-click. These are left points, so let's recalculate the left point to correct them. The trusses will automatically adjust. Now let's also adjust the span of this truss as well, but using the pick left or right method. Since this is the left side, let's use pick left point to adjust it accordingly. Click here, and now the adjustment has been applied correctly. Let's apply the same adjustment to this truss as well. And now this area looks good. Let's review other areas that may require adjustments. Everything looks good here. Let's take a look down here. Looks like these trusses need some adjustments too. Let's use a bounding work line to correct them. Click this and insert. Select these trusses and recalculate right point. Now that looks good, let's proceed adjusting this truss as well. Pick its right point, ensure the right snap settings are correctly configured, and click here. Let's continue reviewing other areas. Let's make the necessary adjustments to this truss as well. Pick its right point and set it until here. After making these adjustments, check the layout again. Let's make a few more adjustments. This truss extended beyond the overhang. Adjust the right point and extend up to this point. Let's also adjust the end points of this truss girder. Some minor tweaks might still be necessary, but we'll move forward for now. Let's navigate to the 3D view and take a closer look at the truss envelopes. Also, make sure the solid option is enabled, as this helps us quickly verify whether the profiles have been generated correctly. Now, let's pan and move around to get a clearer view of how the profiles are shaping up. Most trusses now follow the correct bottom profile, but two of them haven't aligned with the ceiling plane. Let's attempt a recalculation. If that doesn't resolve the issue, we'll delete and reinsert them. Right-click and select Recalculate Right Point, making sure it extends up to the bounding work line. Now, let's switch to 3D view to check if the adjustment worked. It looks like the issue is still there, so instead of recalculating again, let's try re-adding the trusses. Let's go ahead and select these two trusses. Delete them. Place them again here. And then check in 3D. Now, you can see that the trusses properly follow the ceiling profile. We'll take care of the overhang later when we move on to the design phase. Everything is looking good so far. However, some trusses have followed the gable roof profile when they should be shaped to accommodate valley trusses. Specifically, these trusses here, as well as these ones, and these over here. To modify this, select all affected trusses, navigate to the right sidebar, scroll down, and apply a cut and top chord. Click the roof plane where the trusses should be cut, and their profiles will automatically adjust. Repeat this for the opposite side. Apply the cut and observe the updated profile. Continue this process for the remaining trusses that need modification. These changes can be made in layout mode, but using 3D mode provides a clearer visualization. Select these trusses and make sure to press and hold Ctrl key. apply a top cut and cut to this plane. The trusses now appear correctly aligned. However, some still fail to match the lower ceiling elevation. To resolve this, we'll introduce a non-load-bearing wall beneath those trusses. This will force them to recognize the non-load bearing and adjust accordingly. Insert the bearing here, ensuring it is marked as non-structural. Click this, switch to the point-to-point insertion method, then select this point and extend it to this point. We can delete this bearing after designing the trusses, so it's fine to add these for now. Insert and close, then switch back to the 3D view to verify if it worked. The truss envelope seems to have aligned with the ceiling plane. Let's zoom in to confirm. Looks like everything is correct. Let's pan and rotate to the top view. It appears to be correct as well. However, adding the non-load-bearing element caused these envelopes to no longer follow the ceiling plane again. To fix this, select these trusses, check if we selected everything, press delete, and re-add them. Checking again. It looks like the adjustment worked. The truss envelope now correctly follows the ceiling plane. Let's pan around to check if there are any trusses that still need adjustments. Now, looking at these gable trusses, it seems they haven't aligned with the ceiling plane like the others. During the design phase, I'll go over a method to handle this issue, especially if you prefer not to recut all your ceiling planes and risk altering the ones that are already correct. For now, we'll leave them as they are. Before moving forward, let's first correct the top cut for these trusses. Looking good. Doing a final check on all trusses. Everything looks good except for the overhangs, which we can adjust later in design. We can now move forward with adding the valley trusses. To add one, right-click on the scene and select Truss Envelope. This time we'll use Lock to Base, change the snapping distance, and click on the scene to place the first valley truss. However, you'll notice that the span is limited between the perpendicular trusses, which isn't what we want. Going ahead with the insertion first. As you can see, the profile doesn't match what we intended. To correct this, first define the top cuts to establish the correct top chord profile. Add cut, click this plane, add another one, and click this. Then, adjust the bottom cuts, selecting the plane where the valley trusses should rest. At this stage, no visible changes will appear because the span hasn't been recalculated. To resolve this, simply recalculate, allowing the truss envelope to adjust accordingly. Now the profile accurately represents the valley truss. The next step is to insert truss runs along this section, which will automatically generate the valley trusses. As we can see, the valley trusses have been successfully added. Continue placing the remaining valley trusses in the necessary areas, ensuring each follows the correct profile.